Flack math! Give me some math and I'll give you some flack. Flack math!
All right, well, so we talked about slope-intercept form. You guys remember that? Did you watch the video or anything? Were you, because you have issues.
Yeah, my internet shut down.
That's all right. So watch the video when you get a chance. We'll talk about it more today and stuff too. But okay, so we did talk about consecutive integers as well. So now we'll do a problem like that, but then we're going to move on to the next level of that. So we're going to do 77 and 78 today. And today we're going to talk about consecutive odd or even integers. Okay, and our homework will be nada. Because next week is spring break, right? Or is it the following week? Okay. Well, this is a gift that I'm going to give you next week. But this week, oh, I just feel like I just gave you a big gift and then I said, oh, you know what? I have to give it to somebody else. I'm so sorry. So we already talked about it, right? So I forgot it's Thursday. So I'm messed up. So we're just doing 75, 76, and 78. I'm sorry. Elkin I broke his heart. You can tell. All right, so next week though, nada, homework. It's gonna be awesome. But I feel like I just told you what you're getting for Christmas. That's all right. Okay, so let's review a little bit. This was the last example we did on Zoom here. Find 4 consecutive integers such that, okay, dot, 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 and then it gives us the riddle. But how do you say 4 consecutive integers? So if the first one's n, the next one's going to be n plus 1, the next one's going to be n plus 2, and the next one's going to be n plus 3. That's what it means to be consecutive integers. So for example, 4, 5, 6, 7. Those are consecutive integers. Or it could be like negative 10, negative 9, negative 8, negative 7. Because remember, integers could be negative as well. But whatever they are, they differ by 1, right? You just add 1 to get to the next one. All right, so this is the first, second, third, and fourth. Here's the riddle. The sum, or 6 times the sum of the first and fourth is 26 less than 10 times the third. Okay, so that sounds like a crazy riddle. Hey, let me know when you come in, because if you don't come in and if you come in and I don't mark you here, then they're going to call your house and they're going to send a cop car looking for you. They're going to look in the woods, possibly the mountains.
Yeah.
I would look in the mountains for you.
What about me? Should you do that for me?
Yes, and the woods.
Had to make sure.
And the woods.
I mean, the woods and the mountains are kind of like intertwined.
Yeah. There's woods in the mountains. Some of them. Right, you didn't know that.
I'm so tired of being cold. Like, I miss California.
Yeah. All right, 4 consecutive integers. So 6 times the sum. So how do you say 6 times something? Well, that's 6 times the sum of something. Well, if we're multiplying 6 times the sum, we need an elephant butt. Okay, so here's the sum. of the first and fourth. Well, how do you say the first integer? What's the first integer? N. What's the fourth? So here's the first, the second, the third, the fourth. So the fourth would be n plus 3. So see how this is 6 times the sum of the first and fourth? Okay, is, I love it when we get to is, because like that means like we're half done, kind of sometimes. 26 less than, okay, so this less than is like a reverse, remember? So it's not 26 minus, it's something minus 26. All right, and then 10 times the third. Well, 10 times, what's the third? N plus 2. So you do need a parenthesis there too. If you don't have a parenthesis, then it would just be 10 times the first plus 2. Well, that's not going to work, okay? Because that doesn't equal 10 times the third. All right, so let's simplify and solve. I'm going to make this a 2n inside of there. It doesn't matter. You can distribute the 6 to both of those and have 6n plus 6n. Either way, you're going to end up with 12n. Okay, so you get 12n plus 18 equals 10n plus 20 minus 26. All I did was distribute. Now I just need to combine these guys together. So this is minus 6. So this is 10n minus 6, 12n plus 18. Okay, and then we're just combining the minus 10n, minus 10n. You know what I'm going to do? Just because we can. I'm going to get rid of the variable term on this side. And since I'm going to have variables on this, I'm going to do this. Subtract 18 from this side. Kind of get rid of two things at the same time. Are you guys okay with that? It's a little crazy, but I think you're ready for it. Okay? So that cancels. I'm left with 2n equals negative 24, because negative 6 minus 18 is negative 24. Divide by 2 and n equals negative 12. Well, that's the answer to your equation, but that's not the answer to your problem. Your problem says find 4 consecutive integers. So we found the first one. If n is negative 12, then n plus 1 is negative 11, n plus 2 is negative 10, and n plus 3 is negative 9. So those are my 4 consecutive integers. Okay? So Micah, I know you're just joining us. So this is just some review from yesterday or Tuesday. So this was just a review of lesson 76. Now we're going to talk about odd integers. All right, so I'm going to leave this up here. Odd or even, it doesn't matter. But what do you know about odd and even? Give me some examples. Give me an example of 3 consecutive odd integers. Just say it out loud. 1, 3, 5. That's it. Okay, give me an example of 3 even consecutive even numbers. 2, 4, 6. All right, so now in both cases, now this is a very common mistake, but in both cases, what do those numbers differ by? Always 2. So, and when I say 3 consecutive odd integers, some people say, oh, so 1, 3, 5, no. If the first one is odd, if you add 1 to an odd number, that's going to be even. And then this one's going to be even. So no, it's always, whether it's even or odd, you're just adding 2 to each one, okay? And this can keep going. You can have 5 consecutive odd or even numbers, and that's what they'll look like. So let me say this again. Doesn't matter if it's odd or even. Consecutive odd or even numbers are n plus 2, n plus 4, n plus 6. Even though these numbers are even, it doesn't mean that your numbers are going to be even. You're just adding 2. When you add 2 to an odd number, it's another odd number. When you add 4 to an odd number, it's another odd number. Okay? So get that in your head. I don't want to see n plus 1, n plus 3 on your test. Okay? I will put a major frowny face on your test if you do that. And then you're going to feel terrible about yourself all day. And then I've accomplished my goal. Because that's how we learn people, with shame and ridicule. Okay? No, that's not the American way. Well, sometimes it is. Okay. So 77. Let's do an example with odd or even numbers. So find 3 consecutive even numbers. Find 3 consecutive even numbers such that, all right, so even numbers tells us that's our key, that's our table that we have to go by. The first one's n, the second one's n plus 2, the third one's n plus 4, and so on. So 3 consecutive even numbers such that the sum of first and second equals the sum of third and negative 10. Okay, so let's translate this. No problem. How do you say the sum of the first and second? How do you say the sum of the first and second?
2 plus 4.
Well, 2 plus 4.
Oh, wait, is it n plus 2?
So that looks like the second. N plus 2 is the second. So how do you do the sum of the first and the second?
N plus 2.
Perfect. That's right. So n plus 2. So I see how this is the first, and that's the second. So far, so good. And then we've reached our equal sign. Congratulations. Pat yourself on the back. Actually, don't, because Elkin and I did the work. You didn't. Take that pat away. Rub it off.
Giving me more.
Okay, fine. All right, so how do you say the sum of the third and negative 10? How do you say that? Nathan?
N plus 4 plus negative 10.
That's it. Yeah, or minus 10 doesn't matter, plus negative 10 or minus 10, same thing. So see how this is the sum of the third and negative 10. Exactly what it says. All right, simplify and solve. Combine like terms, combine like terms. So you get 2n plus 2 equals n minus 6 or n plus negative 6. Okay, get rid of the smaller variable. Minus n, n plus 2 equals negative 6. Okay, and get rid of the constant on the variable side, minus 2, n equals negative 8. You don't have a coefficient, so you're left with n equals negative 8. Is that your answer? Well, that's your answer to the equation. The question says find 3 consecutive even numbers. So if this is n, what are the next 2? Negative 6 and negative 4. Good job. Does that feel okay? See, it looks like a really confusing and complex riddle, but as long as you have your key here, then just replace words with this information. And that makes an equation that you can easily follow these steps and solve. Okay, let's try another example. All right. I'm going to skip to the third one because I feel like you guys get it. So let's find 4 consecutive odd numbers such that the sum of the first and fourth is 25 greater than the opposite of the third. Okay? It looks complicated and it tries so hard to mess you up. But it's not going to, because this is easy. So how do you say the sum of the first and fourth? Well, guess what? Our key is still the same, remember? Even if they're even or odd numbers, they're always 2 apart. So you're adding 2 every time. Okay, so what's the first? And what's the fourth? N plus 6. Good. And you kind of want to say n plus 4 because it's the fourth, right? But don't do that. So here's the first, the second, which kind of makes sense there, but once you get to the third, then it kind of messes you up. All right? All right, is nice. Good job, well done. Halfway. How do you say 25 greater than? How do you say 25 greater than? Nathan?
25 plus.
25 plus. Now, you could say plus 25 on the end if you want, just like less than. Or you could say 25 plus. But it doesn't matter with addition because it doesn't matter what order you add in. But it does matter what order you subtract in. So if it's less than, you have to say minus 25. But it's not. It's 25 greater than. So it's 25 plus or plus 25. Same thing. You're not gonna get it wrong if you put 25 on the end. But let's just say 25 plus. Okay. So how do you say the opposite of the third? What's the opposite mean in math? Negative. That's it. Opposite just means negative. So I want to oppositize the third. What's the third? N plus 4. So do I just do this? Why not, Elkin? You're shaking your head.
Because there's like terms or.
Well, don't think too far ahead. Why isn't this good enough? Eliana?
Because it's only negative.
Yeah. So you want to oppositize the whole fourth, not just the first part of the fourth, the whole fourth, so you need parentheses. Okay? So that negative sign is just going to be distributed to both. So don't forget that. All right, so simplify and solve. First step to simplifying is get rid of parentheses. Well, that's this guy right here. All right? So while I'm at it, I'm just going to simplify this side. This is 2n, right? 2n plus 6. So that side is simplified. This is 25 plus negative n plus negative 4. Don't forget that 4 needs to be negated as well. Okay, combine these terms. That's 21. So 2n plus 6 equals negative n plus 21, or 21 minus n, or 21 plus negative n, doesn't matter. Get rid of the smaller variable term, which is this guy. So how do you get rid of a negative n? Add n. So 3n plus 6 equals 21. Get rid of the 6. Subtract 6 from both sides. 3n equals 15. So divide by variables coefficient 3. So n equals 5. All right, is that my answer? No. We're asking for 4 consecutive odd integers. Now, if for some reason you get an even number here, then something went horribly wrong. So back it up, fix it, do it again, okay? So it is odd, that's great. So let's plug it in to find the rest. So that's 5, 7, 9, and 11. That's it. And then throw it back in your word problem, see if it makes sense. The sum of the first and fourth. First and the fourth. 5 plus 11 is 16. So far, so good. Is 25 greater than the opposite of the third? The opposite of the third is negative 9. So what happens when you add 25 to negative 9? You get 16. Okay, so it works. Makes sense? Now, you didn't have to do any of this. You could have just started picking all the odd numbers you want, and stop when it works in this riddle. You could do that. Sometimes it's faster. If you get lucky and guess right the first time, then sometimes it's faster. But since they're integers, these might be negative numbers too. So there's obviously an infinite number of possibilities, but your brain will kind of develop shortcuts and you're like, you know what? I think it just has to be a little bit greater than 3, 5, 7, and 9 because I was almost there. I was just a little off. So maybe if I just start with 5 instead of 3. So you could do it that way if you wanted to. All right. But this is so much cooler. All right. It's like you're cracking code. Okay. All right. Let's move on to 78. Done talking about consecutive odd. Okay, so 78. I lied. There's a little bit more to 77, but that's okay. So the last part of 77 is just fraction and decimal word problems. These are nice because all you have to do is translate this. So here's example 4. Lopez covered only 4/5 of the distance. I don't know what they were doing, but Lopez only covered 4/5 of the distance. Okay? If I can't read that. So if she stopped at 112 yards, what was the total distance, or what was the all the way? What was the total distance that she was supposed to go to? I don't know. Okay, you guys get it, right? So we're trying to find the total distance, not what she stopped at. Okay? So here's what I love to do. I just like to go into my word problems and just start translating. I don't even care what it looks like. Lopez, L, covered. That's a verb. You know what we do with verbs? We put equal signs. Only 4/5. How do you say 4/5? 4/5. How do you say of in math? Multiply. How do you say distance? Well, we don't know. So I'm going to put a D there. Everybody okay with that? Now, and then say if she stopped at 112, which one of these does 112 represent? Well, you could do another equation. If she, what's she again? L, stopped, that's a verb, at 112, look what L equals. 112. So this is 112 equals 4/5 D. You know how to solve that equation. How do you solve that equation? Divide by 4/5. Okay. So divided by 4/5, that's 28 times 5. No, yeah, something like that. Divided by 4/5. So 112 times 5/4, that's 28. 28 times 5 is 140. So you've got D, the total distance that you're looking for is 140. That makes sense because she didn't go the whole distance. She stopped at 112, which was 4/5 of the whole distance. So 112 is 4/5 of 140. That makes sense. Okay, let's try another one. Mac. Do you guys know anyone named Mac? Maybe a nickname named Mac. I know some Macs that are nicknames. Mac said the total was $30.24, but not bus, but this was 7.2 times the total. Okay, so what was the total? All right, this just kind of takes the pressure off because you don't have to math it out. Okay, just translate it. How do you say Max said total was 30.24? Well, Max said, that's a quote. So what can you say there?
Just do T equals 30.24.
Okay, yeah, now let's do that for now. Total equals 30.24. But this was 7.2 times the total. So Mac was wrong. So now what do we do? Oh, okay. Well, this isn't the total. This was Mac's total. So maybe we put a little subscript M there. That's Mac's total. Okay, but this, okay, what's this? Yeah, 30.24. It's referring to that guy. So 30.24. And how do you say was? Equals. And how do you say 7.2 times the total?
7.2 T.
Yep, now this is the actual T. So we're going to leave that like maybe TA is the actual total. Okay, now you could have just said avoided subscripts and just say Max said. So Max equals, because said is a verb, Max equals 30.24. But this 30.24 was 7.2 times the total. Now you've got an equation with only one variable. Let's solve it. Okay. So divide by 7.2, divide by 7.2. Somebody want to do that on a calculator? What'd you get? What?
4.2.
4.2. Okay, so let's translate it into money. $4.20. Okay. Cool. That's not bad, right? See how we didn't do any real math until we had our equation. All we did was translate English into math, which is still an amazing skill. All right, ready? Here's example 6. 3/4 of, we know how to translate those so far, tickets had been sold. Okay, so right away you could translate that. How do you translate 3/4 of tickets had been sold? 3/4 T equals, that's our verb, had been sold. So let's put like a little S there. I don't like the normal S's because they look like lazy fives. I don't like lazy fives. I don't like lazy anything. Okay. So, and then the next sentence says, and there are 420 tickets left. So we can say 420 tickets left. Okay, so 420 could equal like L. All right. How many? Goodness, I can't read anything. Okay, so how many tickets? I don't know, maybe, so how many tickets were there to begin with? Let's just go with that, okay? So how many tickets, so we're solving for t, right? Well, the problem with this equation is we don't know what t is. That makes sense because that's what we want to know. And we don't know what s is. But we do know how many tickets were left. So if this is how many tickets were sold, then how many tickets were left? Well, if you know how many tickets were left, what can you say? Now, I can't give you a number yet, but I can give you an expression. So how do you say S? What's another way to say S? How many tickets were sold? Can you guys figure that out? It takes a little bit of thinking, but we could do it. Eliana?
Negative.
Kind of a negative. Yeah, you're going to subtract something.
3/4 L.
3/4 of the L. Well, no. But if 3/4 sold, then what fraction were left? 1/4. So 420 is 1/4 of their total. The other way to do this, to think about S, is this is just your total minus 420. Does that make sense? So you could do this either way. This looks like an easier equation to me. So I'm going to go with this one. So divide by 1/4 just means multiplying by 4. So total equals, what's 42 times 4? 1680 tickets, okay? You could have done it this way. It would have been a little bit more complicated, but you could have done it. Combine like terms, and look what happens. You've got variables on both sides. Get rid of the smaller one. What happens when you take 3/4 t away from 1 t? You get 1/4 t. Put the negative 420 over here. You get 1/4 t equals 420. Same equation. Okay? So either way, you'll get it. So this one takes a little bit of brain work, but always look for the what's left fraction or the what's left decimal. Okay? If you have 0.6 tickets sold, how many are left? 0.4, right. Percents too. If you have 33 1/3% of the tickets are sold, how many are left? 66 2/3%. Yeah.
I didn't listen to the whole number.
All right, good job. All right, now we're moving on to 78. I know you were so excited a minute ago to do 78, and I just gave you a gift, and I took it away. I apologize for that. Feel really bad. Okay. Ready? Okay. So 78. Now this is gonna get fun. It's called rational equations, but we're gonna talk about the F-bomb. Okay, now I've talked about this a little bit before, but this lesson is all about the fraction bomb. Okay, so let me just put an equation on the board, and basically rational equation means that there's ratios in it. There's fractions. Okay, so here's what my equation looks like: y/2 plus 1/4 equals y/6. So far, so good. Okay, well, now you could figure out how to solve this right now. So this lesson is just a shortcut. So really, this is just, we just need common denominators. We got y's on both sides, so we have to get rid of the smaller one. But for now, what we could do is just get a common denominator for all the fractions. What's the common denominator for 2, 4, and 6? That's a common factor. 12, right? They all go. So if I change this all to 12, I'm going to multiply this by 6. I'm going to multiply this by 3, multiply this by 2. So then I get 6y over 12 plus 3 over 12 equals 2y over 12. And then, okay, so now I got to get rid of the smaller variable term. It looks like this guy is smaller. 2y over 12 is smaller than 6y over 12. So get rid of that. Subtract 2y over 12. Subtract 2y over 12. And then you get 4y over 12. And then I'm going to do this at the same time. Get rid of 3/12. Get rid of 3/12. So then you get equals negative 3/12. Okay, so now I've got to get y by itself. So I think if I multiply by 12/4, that would get y by itself, right? Or divide by 4/12, like this, right? Divide by 4/12, divide by 4/12. Okay, now I'm getting something that I recognize here. So then y, I'm going to copy dot flop. Negative 3/12 times 12/4. The 12s cancel. And I'm left with negative 3/4. Final answer, correct. That seemed painful. Why? Because fractions are kind of dumb. All right? Eliana, assist. That didn't work at all. Oh, sorry. What just happened? Because I did bank a little bit off of Eliana, but I still made it in, and you were impressed. You wish you were videoing that so you could show all your friends. But it's in here. Okay? It's in here. Save it. Control S. Okay? All right. There's a better way. I'm going to apply the F-bomb to this equation. So basically the F-bomb is the least common denominator. And all you do is multiply both sides by the F-bomb. So I'm going to do this. I'm going to multiply 12 times y over 2 plus 1/4. And then 12 times y over 6. Okay, now this looks complicated right now, but it's going to save you a lot of energy. Okay, so this is just distributing and simplifying, right? What happens when you multiply 12 times y over 2? What can you cancel? The 12 and 2, right? So let's just rewrite it. You don't have to do this, but let's just rewrite it like this. So I'm just distributing the 12 to the fractions, and then I'll do one more over here. Then I'm going to bring out my new red pen, and then I'm going to cross cancel. 1, 6, 1, 3, 1, 2. Okay, so now when I multiply, what do I get? 6y plus 3 equals 2y. Look at that nice equation. Doesn't that look nicer? So get rid of the 2y, 4y equals negative 3, divide by 4, y equals negative 3/4. But, so this step isn't necessarily necessary because you can probably do that in your head. You can cross cancel the 12 and 2, and that's a 6. So 6y plus 3, because that cancels to a 3, equals, okay, that cancels to a 2, so 2y. Okay? Now, do you see why we multiplied by 12? Because 12 in one step canceled all of the fractions, got rid of all the denominators. Why did 12 do that? Because it's the least common multiple of those three numbers. Now, you could have multiplied everything by 2, and then you got rid of that, and then you made this a 1/2, and you made that a y over 3, and then you could have multiplied everything by 3, and you could have gotten rid of that y over 3, but that would have been like a, now it's a 3/2, which is weird. And then you multiply by another 2. You could have chunked it out, but one bomb killed all the fractions. There's no more fractions. And all it took was one bomb. So the F-bomb is the least common denominator of whatever fractions you see. Okay? So if you need to multiply it out like that, you can. Now let's go back over here 1 second. At this stage, we rewrote all the fractions with our least common denominator, right? If I would have multiplied everything by 12 here, look what happens. 6y plus 3 equals 2y. Okay, so you could do it this way too. Find your common denominator, write everything with the same denominator, and then you can F-bomb it. Drop that fraction bomb, which is 12. Okay? All right, let's do another one and try to figure out what the F-bomb is and drop it. But not out loud, because that's awkward. Okay, here's example 2. 2x over 7 minus 3x over 2 equals 1/3. Okay, so we're going to try to do this one in our head to get to the next step. What's the F-bomb of this equation? It's a little bigger number, but I'd rather have big numbers than fractions. Any day. Yes, Nathan.
42.
42. Okay, remember that's the answer to everything in life, apparently. So if I multiply both sides by 42, let's just throw that there. So let's do this in my head, okay? Oh, you can do it in your head. You don't want to do it in my head. You don't want in there. Once you get in, it's hard to get out. It's fascinating, but weird looking, okay? So what happens when you multiply a 42 times something over 7? What happens? What does it cancel to?
It cancels to 6.
6. So now we can do this math in our head, right? What's 6 times 2x? 12x. Right? Okay. So see how we can't just do this. Okay, 1, 6. Because it's different when we multiply by something over 2. What does that 42 become when we cancel it? A 21, right? So now we're distributing a 21 to a 3x. That's just negative 63x, which again, they're big numbers, but I'd rather have big numbers than fractions. Okay, what happens when you cancel that? What are you left with? Can you do that? How many times 3 go into 42? If you don't know, then use your calculator, but it's 14. So that's 1 and 14, so 1 times 14 is 14. Now I have this equation with little bigger numbers, but again, this is not bad, right? Okay, so combine like terms. These are both like terms. So subtract 12 minus 63 and you get negative 51, right? X equals 14. So now divide by negative 51. So nothing goes into both of those, so you're done. It's better to have the negative on top, but this is okay. 14 over negative 51. That's it. That's your answer. Yes. Bathroom? Yep. Check. Okay, let's try to complicate it a little bit if we can. But really, there's just 2 steps. Find the F-bomb and drop it. Okay? And then you'll get an equation with bigger numbers, but it definitely makes it less complicated because fractions are complicated. Even if you are good at fractions, they just complicate things just a little bit more. Okay? All right. Here's example 3. 3y over 2 plus 8 minus 4y over 7 equals 3. So first step, remember there's just 2 steps. What's the first step? Find the f-bomb. What's the f-bomb? 14. So I'm going to multiply both sides by 14. So if you want to do it like this, you can. And then you have the freedom to just kind of cancel it. You want, you're already distributing the 14. Okay, doesn't matter. All right, so I'm going to take out my red pen because I'm going to cross cancel the 1 and the 7, the 1 and the 2. So far, so good. You're distributing the 2 to both of those, right? So you got 16 minus 8y, and then you got 42 right there. Bigger numbers, but less complicated. Combine like terms. 13y plus 16 equals 42. Subtract 16. 13y equals 26. Y equals 2. Nice. So you don't have to do it this way. If you want to find a common denominator, rewrite the fractions with the same denominator, 14, you're welcome to do that. There's nothing wrong with that. But you miss out on the pleasure of dropping an f-bomb, okay? And it is satisfying to just cancel all the, it's wrong to kill. But if they're fractions, it's okay. You can kill fractions, okay? So kill the fractions. Kill them dead, all right? Shouldn't feel guilty about that. All right, one more example and then we'll call it a day.
They won't be lying again to us.
I know, you can't trust me. That's the problem with lying. It's harder to trust somebody when they lie to you. Okay, ready? See if you can do this one on your own. Here's example 4. X plus 1 all over 4 minus 3/2 equals 2x minus 9 all over 10. Ready, go. You have a free problem set? Yeah, it doesn't look that kind of picture. How about you get free problem set if you get it first, and then you get Flack points if you just get it. You have an answer, Nathan? Hide it. Don't show anybody. Well done. I think this deserves 2 Flack attack points, don't you? You get it? You get 2 points. Stop. All right, sorry. Don't get it. Don't get the right answer. Do you? Okay. Okay, keep trying. You might have just subtracted when you're supposed to add, or add when you're supposed to subtract. We're doing a healthy competition. Trying to solve that equation if you want to do it. Oh, not yet. Ready? Let's see if we can start. Okay, so that's all right. And now, we're it is not. Oh, okay. So this 3 here, you multiply this one by you pulled me into your trap, but I believe you. Where's your word? What do you got? You got this is so we're 20, multiplying 20, but when you multiply 20 times that first fraction, that 4 cancels it. And really you're multiplying 5 times x plus 1. So the point is to be able to cancel that 4. Okay. All right, ready?
Wait.
Okay.
Is it x equals 7?
Yes.
Really?
Yeah.
Oh my gosh, I'm a math wizard.
I'm going to give that to you as well, Riona. Where are you at, Eliana?
Wait,
I started over because I got 11 and that's not right. So I'm trying to figure out what I did wrong.
11. You guys notice that 11 is like never the answer?
It's weird, isn't it?
I don't remember 11 ever being an answer. I'm just gonna go home and square root 121 over and over just so I have that satisfying feeling. I'm not gonna do that. I don't do that. Okay, so what's the F-bomb? Oh, you can do 40 too. And here's the beauty of the F-bomb. If 20 kills everything, then 40 is definitely gonna kill it. And 60 is gonna, any multiple of the least common denominator is an effective F-bomb, okay? But 20 is all you need because 20 will cancel all of those numbers. Now I could just do this whole thing and then multiply this whole thing by 20. But what I'm gonna do, just to make it, since I have to distribute that anyway, I'm just gonna do this. Okay, everybody okay with that? All right, so I'm gonna take out my red pen, and this is the important part, Zan, is the whole point of this is to get rid of these fractions. So this cancels, and now that's a 5. So remember cross-reducing when you multiply? That's great. So that's why we do that. So now we don't have a denominator there anymore. So now when you distribute, you get 5x plus 5. Oh, well 80 would work too. Yep, so you get 20x plus 20. Yeah. Did you, okay, so your way would still work. So let's pretend that, and 40 would work as well. So here's yours over here so far. You get 20x plus 20. So far, so good. So if 80 is the F-bomb, you could just multiply all of them together like Zan did. There's nothing wrong with that. You don't have to do the least common denominator. You just have to do a common denominator. So this cancels to 1 and 10, right? So 10 times 3 is minus 30. But if it was Zan's 80, it would have been 40 times 3. Did you get 120 there? Yeah. Okay, so far so good. Good job. All right, this 10 and 20 cancel to 1 and 2. So then I get a 4x minus 18. So if that was an 80, it would have been a 16x minus 72. Is that what you got? Yeah. All right, good.
Then I added all that.
Okay, so you might have just combined like terms wrong or whatever, but here's our like terms here. That's the only like terms. So I get 20x minus 100, not 1,000, equals 4x minus 18. Okay, that's fine. So that was, yeah, so 16x minus 72, and then you would have gotten, oh wait, I'm doing it down here, and I should have been, sorry, minus, or equals 4x minus 18. So this one is, what was that? 16x minus 72. Okay. So 16x minus 72. Up here, we're going to combine these guys here. So this is 5x minus 25 equals 4x minus 18. So now I'm going to get rid of the smaller variable term. And at the same time, I'm going to get rid of 25. But adding 25 to both sides. So I get x equals 7. No, yeah, 7. Okay, but over here in Zan's equation, I'm going to get, that's a 16x, right? I'm going to get rid of 16x. Did you get rid of 16x? Yeah. Okay.
So then I got 4x minus 100 equals 72.
Okay, so how do you get rid of minus 100? Add 100. Add 100. Did you say 172?
72. Oh, wait, yes.
Okay, that's where you went wrong. So this is 28, right? So 4x equals 28. What does x equal? Okay, great job. So this is why, this is a great example, guys, of why you show your work on your test. Because Zan did everything right, but if he just said x equals 43 on his test, all wrong. He loses, most of the time it's 4 points a question, 4 percentage points. He would only lose 2 because he did more than half of it right. Okay?
I got it wrong. I did 20 plus 100
Yep.
20. So then I didn't do minus. Then I got 20x plus 100.
Yep.
6x.
So, math insurance, show your work. Any questions? All right, good job, guys.
Flack!